Hi everyone, it's Mrs. Martello. We're going to look at section 1.5. In this section, we are rewriting literal equations. So a literal equation is just an equation that has two or more variables. When you rewrite it, you're basically just solving for one of the variables in terms of the other variables. So our goal is really just to isolate the given variable. Whatever variable they tell you, you just want to isolate it and just work around all the other constants and variables that are there. Okay, we're going to look at some examples together. Let's take a look at example 1. In example 1, we have 3y plus 4x equals 9, and we're going to solve for y. So we're solving this equation just like any other equation, but there are just two variables in it. I know that this x is here, but that's okay. We're just going to treat it as if it were part of the equation, just a regular. So if I'm trying to solve for y, my first step is I want to get rid of anything being added or subtracted to the y, which is this whole term 4x. Since it's being added, let's subtract 4x from both sides. When I do this, now I'm left with 3y equals 9 minus 4x. Notice how I did not combine these together. These are not like terms. The 9 does not have an x, but the 4 does. So I cannot combine them. They're going to stay separate. I want to show you something that whenever you write an equation, it's more likely that you're going to have the variable term before the constant term. So I'm just going to rewrite this and switch these two terms around. Say 3y equals negative 4x. And then this is a positive 9, so plus 9. And when you write equations, this is the normal setup that you always have a variable term before a constant term. You don't have to write it this way, but you'll see it like this most often, so it's important for us to recognize how to write it appropriately. Let's keep going. We're going to solve for y. My next step is I'm going to divide by 3. So I'm going to divide away the 3, get the 3 out of here. And when I divide the right side by 3, technically the entire side gets divided by 3. So this term gets divided by 3, and this term also gets divided by 3. Now when I draw it like this, it makes it look like a heart to me. So I call this the heart method. And you may hear me refer to this later on throughout the course, but this is just me reminding myself that I have to divide each term by 3. So let's write our equation. Y equals, on this first one, it would be negative 4x over 3, plus on the second one, it would be 9 over 3. I want to simplify my answer as much as possible. Whenever we write our answer, we could leave this first term like this, but normally our numbers and our variables are separate. So I'm going to write it as this fraction as a coefficient and x as the variable being multiplied. So I'm going to say my answer here is negative 4 over 3 times x. So notice how I just put the numbers in their own fraction and I just pushed x to the side. Plus, let's divide these numbers over here and I get 3. So that would be my answer. Y equals negative 4/3 x plus 3. Let's look at some more examples like this. I'm going to go down here and look at some monitoring progress questions. I'm going to look at monitoring progress number 1. Let me write down the equation, and you should be copying these notes with me so that you can refer back to them. Monitoring progress 1. 3y minus x equals 9. And again, we're solving for y. Okay, let's isolate the y. So my first step is I'm going to get rid of anything being added or subtracted from the y, and that's this minus x. So let's do the opposite, and let's add x to both sides. Here I have 3y equals, these x's canceled out. Now this is this 9 plus x, but I'm going to put it in the other order. I'm going to put the variable term first, and the constant term second. So let's write it as x plus 9. Let's keep going. We're going to solve for y. I'm going to divide both sides by 3. On the right side, remember both of these terms get divided by 3, so we're using the heart method again. So my answer here, y equals this would be x over 3 plus 9 over 3. Let's simplify this answer. Now technically, remember, there's a 1 in front of this x. I'm going to put the numbers in their own fraction and push x to the side, making this y equals 1/3 x plus, divide these numbers over here, and I get 3. And that's our answer. Let's do monitoring progress number 2. We have 2x minus 2y equals 5. And again, we're going to solve for y. So let's get the y by itself. We're going to get rid of anything being added or subtracted from the y, and that's this 2x. This 2x is a positive 2x, so I want to do the opposite and subtract 2x. This negative goes with the 2y, but this is a positive 2x, so I want to subtract because 2x minus 2x cancels out. And let's minus 2x from the other side of the equation. I'm left with negative 2y equals, and I'm going to write the variable term first, negative 2x, and then the constant term. This is a positive 5, so plus 5. Let's keep going. I'm going to solve for y. Let's get rid of this negative 2. We're going to divide by negative 2, and I'm going to divide the whole side here by negative 2. Let's use the heart method and divide each of these terms by negative 2. My answer, I get y equals, now I'm going to think about this and kind of jump ahead. Think about my numbers, negative 2 divided by negative 2, that would be 1x, or I could just say x. And then over here, when I divide this, I can leave it as a fraction. This would be negative 5 over 2. Or if you want to change it to a decimal, you could say x minus 2.5. Either one would be fine. I personally like fractions better, but that's totally up to you, whatever you prefer. Next, we're going to look at monitoring progress 4. In number 4, we have y equals 5x minus 4x. Notice in the directions here, it now says to solve for x. So just make sure that you're focusing and making sure you're reading the directions carefully so you know what variable to solve for. In this equation, the first thing that I notice is I have like terms that I can combine. Let's combine these like terms, get them so that they are together. This would be y equals 1x. Or in other words, y equals x. Well, if I'm solving for x, this is the same thing as saying x equals y. So I'm actually already done with this equation. I have no more to do with this one. Let's look at some, oh, do you hear my cat in the background? That's my crazy cat that I was warning you guys about. We are going to look at some more examples. These are real world examples. Let's take a look at example 4. Okay, in example 4, we are going to use formulas and solve for a specific variable in a formula. It says you own a rectangular lot that is 500 feet deep. It has an area of 100,000 square feet. To pay for the new water system, you are assessed $5.50 per foot of lot frontage. Find the frontage of your lot, and then how much are you assessed for the new water system. So the first thing that we want to do is we want to figure out what's going on here. We have 500 feet on one dimension, and then we don't know the width. We are talking about the area of this land here. Remember that the formula for the area of a rectangle is length times width. I want to figure out what is the width. So why don't we solve this equation for W and make the equation in terms of W so that I can easily find out what W is. Well, if this is length times width and I want to solve for W, all I have to do is get rid of this L. Since they're being multiplied, let's divide both sides by L. And I would be left with A over L equals W. Or I could say W equals A over L. And that would be the first part of this problem, solving this equation. Okay, I'm just going to follow along here and plug in the numbers that they give me. If my equation is W equals A over L, let's plug in what I know. The area, they told me, is 100,000 square feet. And the length is the 500. They show us in the picture right here. So that leads me to believe that W equals 200 feet. Okay, that would be the first answer. What is the frontage of your lot? That would be the W. We just found that here. Okay, our next step is now we are going to find the cost. So for part B, I'm going to do it up here. For part B, it's basically we want to find out that it's $5.50 per foot for the frontage. So it would just be $5.50 times the 200 feet we just found, and that would equal $1,100. Let's do some more like this, and we're going to focus more on solving the equation for a specific variable. I'm going to go to the next page. So I'm now on page 38 if you're following along with me, and we're going to look at example 5. So in example 5, it says we're going to solve the temperature formula for F. Let's write down the formula. It's C equals 5/9 times F minus 32 times the quantity of F minus 32. Let's solve this equation. If I want to solve for F, I know what some of you are thinking. Maybe we should distribute. But if we do distribute, then that gives the 5/9 into this equation and it makes it more complicated. Instead of distributing, the best idea would be to get rid of this 5/9. Let's get rid of the fraction first. So if we want to eliminate the fraction, we are going to multiply by the reciprocal of this fraction. So the reciprocal is when you flip the fraction upside down. I'm going to multiply this side by 9/5, and that would simply cancel this fraction out. I'm going to multiply on the other side as well to keep my equation balanced. Let's multiply this side by 9/5. Now our equation becomes 9/5 C equals F minus 32. And now I can easily solve for F. Let's add 32 to both sides. I get 9/5 C plus 32 equals F. And I'm done. I solved the equation for F. We're going to look at one more, and it's going to be example 7. Let's go over here and take a look at example 7. It says you deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50 in interest. What is the annual interest rate? So we're going to first start off with the annual interest rate formula, and we want to solve that simple interest formula for R. Let's write this equation down. I equals PRT. I equals PRT, and we're going to solve for R. So let's think about how we're going to isolate this R. Think about what's going on here. The P is being multiplied by the R, and the T is being multiplied by the R. I need to get rid of the P and the T. Since they're both being multiplied, I can divide both of them away in the same exact step. If I divide by P, the P's would cancel out, and if I divide by T, the T's would also cancel out, leaving us just with the R, which is what we want. So I need to divide the other side by P and T as well. Let's write our answer. I over PT equals R. Or I can write it this way. R equals I over PT. And that would be my first step. That would be my equation solved for R. Let's finish up this question here. Let's go back and read what it says. We're going to plug in the numbers and we're going to find what R equals. So R equals our interest, they told us in the problem, was $162.50 over our P stands for the principal, and that's the original deposit. That's the $5,000. And the T in our equation is the time. So since it's 6 months, that's half of a year. So we're going to say half, or 0.5. We can just put this all into our calculator, or we can do it one step at a time. 162.5 over 2,500. And when we put this into our calculator, we end up getting 0.065. Now, since this is a rate, I want to change this to a percent. So let's move the decimal over 2 places, which gives me 6.5%.